Welcome, everyone. I'm Rachel Green, Digital Communication Specialist here at McNaughton-McKay Electric Company. Thank you for joining us here on our monthly Mac and Mac Live panel discussion, the Industry Expert Exchange. Every month, a panel of specialists from across our 5 regions covers a new topic, exploring the latest and greatest technology developments and challenges in that focus area. We host these live streams once a month on Thursdays at noon Eastern, so you can join us on your lunch break, or you can always watch the recording afterward. As you join, say hello in the comment section. Let us know where you're tuning in from today. I'll have my eye on those comments as we go along, and feel free to ask questions at any time throughout the session. There's no need to wait for a Q&A portion at the end. We'll answer your questions in real time in our discussion. Now, if you have a question that we can't get to today, or if you're watching this as a recording, you can always reach out to us at macandmaclive@mc-mc.com. That email address is in the description of the video below, and I'll repeat it again at the end of our session. This month's topic is networking, and before we jump in, let's take a minute to meet our panelists here today. I'm going to ask you all to introduce yourselves. We'll go around the screen. If you can give us your name, your area of expertise, and where you're joining us from today. Let's start off with Jacob.
Hi, everybody. Jacob Crosby. I'm a solutions architect in our network services group, and I'm calling in from Michigan today.
Great. Nick, you want to go next?
Hi, I'm Nick. I'm the industrial network and security engineer covering the Ohio region and Michigan as well.
Wonderful. Kevin?
Morning, everybody. My name is Kevin Riney, and I am also a network security engineer in the Carolinas region. I'm calling from the Charlotte area.
Wonderful. And Janie?
I'm Janie West. I'm solution architect located here in Georgia for the network and software services team.
Excellent. Thank you guys for being here. Let's go ahead and get started with our topic. Before we do too much of a deep dive here, let's kind of give some context for what we're talking about today. So Jacob, if you can talk to us a little bit about, what is networking? What kind of networking are we talking about today?
Yeah, so we're going to talk about industrial OT, operational technology networks. I think many people are familiar with IT, information technology networks, and how that connects business systems, office computers, printers, servers, etc. Well, the same concept applies to OT for discrete manufacturing and process industries. In OT, there are controllers, sensors, application servers, multiple things that we need to be connected to communicate information. And we want to do this in a reliable fashion. So it might be okay in IT if an email takes 1 extra second to send, but in OT networks, the communication is critical, and 1 extra second could lead to potentially nuisance faults or potentially injuries from equipment that moves. So with that in mind, we're going to talk about common challenges that we see in OT networks, such as poor network designs, protecting your network and its assets, and then also what can be done to create a reliable and robust network that provides you uptime for production. So that's what we're going to focus primarily on today.
Wonderful. Thank you for that. Janie, I'm going to direct this question to you to kick us off. What constitutes a good network design?
Well, as Jacob just mentioned, we work with manufacturing and industrial locations, and many times these locations, have equipment that's been in place for years. And they will have started out with a lot of, we'll call it legacy networks and things like that. And they will have evolved over time. And many times, while they may have started out with a design, they may not have one today. So what we talk to customers about is, how do they create a new modern design? And there are a number of things, you need to take into account. And I would say the first 2 things are your logical and your physical network. Your physical network is obviously how it's physically laid out for your facility. It's got to have a backbone. There are tiers that you should take into account. It needs to fit your different process areas from a physical perspective. And then logically, how you want the network to perform. And then that gets into a number of the other areas, you need to think about. Today's modern networks are usually also segmented. One of the things you see in a lot of legacy networks is they can be flat, where people have used unmanaged switches or managed switches and no segmentation. I mean, it could be done a variety of ways, but today, because of security, because of performance reasons and all that, you want to look at having network segments work as a segment, where it's important they get the information they need and not get everything else that doesn't pertain to that particular segment. You want to consider managed switches. Managed switches help you troubleshoot networks better. They help you manage your traffic better than unmanaged switches. So today, most networks are going to be a combination of switches. You may have some unmanaged switches, you may have some lightly managed switches, and you're going to need a fair combination of managed switches. You need to look at things like firewalls. You need to look at access to that network. And I think we're going to talk a little later on a little more about security and all of that. But who has access to that network? And it's not only from an external perspective. Everybody thinks about cybersecurity and a bad party coming in through the internet, but you also need to take into account internal access, because a lot of manufacturing or industrial networks, the way they get infected are actually internally, and it may not even have been planned. You could infect it without even knowing that you did that. So understanding the access to your network, both from an internal and an external perspective, is important. And then I guess the last thing I'll mention is the resiliency of your network. Your network runs just about everything today. So if you have a network with single points of failure, anything's going to take you down. It can take you down for a considerable length of time. So in your new network design, you need to take that resiliency into account, and how you make sure you have a robust network that can respond to a lot of different things that may happen in the course of a day of manufacturing.
Yeah, that's great. Anyone have anything to add to that, or did Janie pretty much cover it?
Andy did a great job of covering a good umbrella of what a good design is. Some of the challenges that we see as we're going into the plants based on that design that was done 10, 15, 20 years ago, they include things like a really flat network, and you'll hear technicians talk about flat networks. What that means is that you have a lot of systems operating on the same network without any subdivisions. Janie mentioned subnets, right? Subnets are a good thing in specifically in industrial networking because of the time required for good communications to happen, as Jacob mentioned as well. If you don't have those subdivisions, if you're running on a very flat network and you have a lot of devices, it can cause problems all by itself. Rockwell has kind of a rule of thumb that they've shared that suggests if you have more than 200 devices, 200 IP addresses talking on a network on a subnet at any given time, you might have too many. It's not an absolute. There is fudge room there, but that's a good earmark, good rule of thumb to follow. And subdividing your network is a good part of design in networks that are looking to keep their functionality going into the future as they grow.
That's a great point, Kevin. And I think one thing to mention too, the design also can include the configuration of those devices. So let's say we have 200 devices that are on a particular network. It also depends on how those are configured too, how they're set up to communicate, whether that's multicast traffic or broadcast traffic, unicast traffic. If they're set up for unicast where they're talking one-to-one, it's going to create a lot less traffic on the network. So although we might have a numerous amount of devices on the network, when they're configured in a certain way, that way they can talk one-to-one, it's going to be much more efficient overall.
The other thing, and we get called in to help customers troubleshoot networks. And I would challenge any of you, have you tried to go troubleshoot a flat network that has a lot of devices on it? Try to figure out where your problem is. It's very, very challenging to go do if your network isn't segmented. And there's a lot of good tools to go help you go do the troubleshooting, but without having a segmented network and properly set up and all that, is very hard to go troubleshoot and find out where all of your issues are.
Yeah, and networks often grow organically, right? They might have been designed are initially designed for what serve the purposes and the number of devices and nodes that are going to be out there. But as we continue to get towards this age of, Industry 4.0, IoT, all these smart sensors, smart devices, more devices on the network and needing to talk to each other, it's growing rapidly. And all because you do a network design today that might meet your needs, it's going to be ever evolving and it's going to be changing over time.
You both bring up a really good point about knowing what's on your network and the design portion of it. And in a lot of cases, like Janie said, designs are 20 years old or more.
Mm-hmm.
One of the biggest problems that we find in networks today is that as an organization has grown its network organically, they may have fallen down on documenting what's on that network and where the pieces and parts are, where they're located physically as well as where they're located logically. And all of that is critical information to help you troubleshoot. I think someone mentioned, helps you know where to replace obsolete devices. And it's just having that documentation cannot be understated. And keeping up with that documentation, which is probably the most tedious part of the job, is absolutely critical and absolutely necessary.
And Kevin, to your point, having that documentation, I mean, you get all these production floors that are running 24/7, and a lot of times a night shift is a skeleton crew. So if you have a device or a switch or something that goes down and it's a flat network, it's a needle in a haystack. But if you have this thorough accounting of your network, that technician who may just be starting, could be his first month, or again, it's night shift, can open up this sheet and say, oh, I know where that is. And you're up and running in an hour versus waiting for first shift, who may have a little bit more experience, come in.
Absolutely.
Excellent points. Nick, I actually have the next question here for you. How can you know if your network is performing well?
So we've touched kind of on all these questions a little bit on this, but the gist is, are you experiencing network drops or delays in a robot arm, maybe grabbing a part, or a conveyor line stopping, a bottle filler, anything like that, that when things are going through the production line where there's a halt or a stop, an alarm overhead, those are some good indicators that, maybe there's a congestion of traffic. Jacob had alluded to multicast and unicast traffic. That kind of plays in conjunction with a flat network. Each device is configured to talk differently. You've got drives that are more chatty than others, where a PLC and an HMI typically are a unicast one-to-one handshake. So to really know if your network's performing well is how many times during a day do you maybe experience an alarm or a drop or a production line going down is a good measure. Or in that instance, if a programming change may need to be made on the floor, if you plug in one more device, if that maintenance or technician plugs in their laptop and then the line goes down, that's kind of a good health check that, hey, my network could be a little bit congested, or I need to make some improvements here.
We have a question in the comments here, actually, that's speaking a little bit to what we've been talking about. The question is from Jay Lloyd. He asks, is there a software package that you would recommend to take inventory and monitor an industrial network?
There's a few different tools out there. Panduit has a few good options. So does Rockwell Network Manager, which is actually kind of being phased into more of your asset center. So if you really want that good accountability of your network as far as what's out there, and then let's throw in some disaster recovery, because this asset center can do disaster recovery. It can back up your assets that are out there in the instance that you have something go down. It takes a good accountability of what's out there, but then it's also getting kind of shifted into a network standard where you can not only keep track of your assets, you can kind of see some health checks on what's out there. And there's many tools out there. The borderline is when you think of IT and OT networks, IT is typically kind of your bandwidth. I need to get information to the phones, the printers, the laptops, the cell phones, the wireless access points. But when you're shifting to the automation floor, you're thinking about sensitivity, because everything works in milliseconds. When I hit that e-stop, I want whatever it is to stop. I don't, want to hit the e-stop and then the robot arm stop 2 or 3 seconds later. You could have a large tooling issue, which could cost you hundreds of $1,000s to retool a part, or, it could be somebody's safety. So when you're looking at the tools to monitor your network, you kind of want to put that line in there and say, what is going to be less intrusive to my network? There's many industrial monitoring tools out there, but there's also many IT tools like your SolarWinds that are trying to pull all this information as quickly as it can, so that way it can give it to you in a real time, but that may not be what's best for your automation floor. So looking at something kind of more Rockwell or Panduit, there's some other ones out there that are kind of more industrial focused, but just making sure how intrusive the product is to your network.
To piggyback on what Nick said, you can't understate the importance of disaster recovery and backups. Asset Center does a great job with all of that. It's what I refer to as disaster recovery and backups is often overlooked on the industrial floor. The servers, they're all backed up. The IT guys, they've got their backup systems. Some of them are going off site, some of them are going to internal devices. Frequently, the programs that run the systems that make the money for the corporation don't have backups. They don't have a way to keep that information, that program around if something happens to the machine, to the facility, to the personnel who run it. So backup and disaster recovery can't be understated. And again, Asset Center is a really good tool. It has disaster recovery built right into it. So it has a great capacity to help with that. One additional point I wanted to piggyback on what Nick was saying is that the metrics on the OT side and the metrics on the IT side are vastly different. In a typical framework, an IT person is going to look at the bandwidth of a network and identify whether or not it's healthy. By comparison to that, an OT network is more dependent on how quickly information goes from point A to point B. And that is not always a factor of the bandwidth. If you have devices that are overloaded, they can't process the packets fast enough to respond in time. So it's really important to know not only what's on your network, but what the communications channel looks like for those devices, so that you can weed out the traffic that's not necessary for the OT world and focus on the traffic that is beneficial. Jacob mentioned the unicast, multicast, and broadcast. As we look at networks, we assess them for how much broadcast traffic and how much multicast traffic is on that network, and we try to minimize that. We can't really eliminate it completely, because there are some valid functions for broadcast messaging and unicast messaging, but we want to minimize that because the nature of that communication type can overload many devices that don't need to hear the information. So looking at an OT network and setting your metrics appropriate to an OT world, and looking at your IT network and setting the metrics appropriate for IT is really an important concept as well.
I think a couple of things I'll add to the conversation, because I think the question was originally about for doing network monitoring and all of that. And then we got into the fact of, there's good things to do monitoring, to map your topology, to do troubleshooting. And then as you brought up, I think both of you brought up the fact that, then we can add things like Asset Center that do the backups. And it's important to point out, these are all good things for a security plan as well. We in the manufacturing environment haven't always been on the forefront of planning secure manufacturing environments. And you've got to be able to plan all of this stuff to be able to detect things that are going on. If you're using unmanaged switches, It's tougher to go back them up and know exactly what happened. It's tougher to go map a topology of that. So those are all good things that come into your network design to go do that, and to be able to have that backup plan, to be able to monitor it, to be able to troubleshoot it appropriately. All of that kind of comes into play. And then, you know, the asset center comes into play a lot in your security plan. If you do have a hacker that comes in, you know, you need to have an immediate backup that can come and bring you back up and running. And not only that, what it does is it tracks. Most manufacturing plants have OEM system integrators. They come in, they maintain their machines. You know, you've got to have software that gives them access. It gives them access really to just what they should have access to. So that's all part of that, the tooling that you now have to have on that modern network.
Great, thank you, Janie. And that actually leads us to kind of shifting gears here and talking about security. You know, cybersecurity and network security are really big. We see it in the news all the time. Kevin, I'll start with you with this question. What are some of the security threats industrial networks face today?
Well, I wanted to take a step back on that question and touch again on the concept that the IT metrics for security and OT metrics for security are slightly different. They overlap and they handshake a lot, but there is, you know, the IT guys, they're looking mostly at the security from the outside world in. Right? They're the boundary protection. They're the guys on the castle wall. They're keeping the bad guys out. That said, the deepest threat typically for an operational technology network, the factory floor network, is not the outside world coming in, but rather the inside people on the computers in the network making a simple mistake, accidentally changing a switch that needed to be set properly. So the security that the OT world has really depends in large part on dividing the IT space from the OT space in a way that both can function well, communications can happen properly across the boundary, but unintended processes or unintended problems, extra traffic from Windows computers, things like malware that gets infected on a computer, they don't cross over into the OT world. And so in the reference architecture that Rockwell puts out, they published it a long time ago in conjunction with Cisco. They suggest, and we support wholeheartedly, a firewall between the OT space, the factory floor space, and the IT enterprise space. In that way, you keep a good division between the major threat area for an OT space and your assets. Certainly bad actors, hackers, are a problem. But even as you look at some of the most recent violations, down here in the South, we had the Colonial Pipeline ransomware attack. Big problem for the area. Cut off gas and fuel, oil for a large part of the southeastern seaboard. In that instance, the attack did not hit the OT space. It did not hit the factory parts and pieces that were running the pipeline. Colonial Pipeline could have continued operating using what they had manually. They just wouldn't have been able to use the computers that were attached to the network, because that was what was infected. The computers, the PCs, the Windows servers. That was the data that was ransomed back to Colonial Pipeline. So that demonstrates that there's if you have a barrier between the IT space and the OT space, you're creating an additional layer of security for, again, what makes you money, the industrial pipeline, the industrial processing line. One other thing I did want to add on, I've got a security background myself. One of the worst mistakes anyone can make in an IT position or an OT position that has responsibility for security is being overconfident. Believing that your organization, just because it's this small or just because it's this obscure, is outside the attention of the bad guys. And I want to say that if you had an accounting of everything that was trying to get through your firewall now on the outside, you'd be surprised. It happens every day, all day. And it's just a matter of making sure, in most cases, there's a firewall there. It's doing a great job. But you don't want to rest on that. You want to make sure that you're updating. You want to make sure that you're patching. You want to make sure that the firmware keeps updated. And that is something that the OT side of the fence has taken a little bit lighter than probably it should have. The patching, the firmware updates, and making sure that the software parts of the industrial production line are updated and protected against the bad guys.
Great points, and a great way to kind of shift our focus on what cybersecurity can mean with the internal focus as well. Janie, you had mentioned earlier in our discussion access points and how those access points are not just external, they're also internal. So I want to direct this question to you. How do you identify both physical and digital access points in a network, and what are some of the best practices for accessing the network?
Well, I think to carry on with what Kevin said, I think that there's that whole identification of access. Who has access to your OT network? And a lot of times we're in manufacturing and industrial environments, we're pretty open about it because they have system integrators, they have OEMs, they have people across 3 shifts that have to go fix stuff and know how to do things. So I think in the past we tended to be very open and maybe not attentive to some of the things that we need to do. So, it starts out with identifying, who should have access. We just had a conversation with a customer here not long ago, and he was talking about how, they've had employees, they've migrated off to different jobs, maybe even in the same company, but they still have access to everything on the OT environment, and they really probably shouldn't do that. So it starts with understanding, okay, who all should have access, and how do I restrict that access to who should have access, and then make sure I eliminate anybody who doesn't. So that's where you get into things like firewalls. I think Kevin and Nick both brought that up. You're going to put a firewall between your OT network and your business systems, because there's things that need to go back and forth between those environments, but that there's a lot of things that you should be kept separate. Also, when you have people come in, if you're going to have an OEM come in, they're going to maintain a machine in your environment. They should only have access to what they're going to maintain. Letting them in on your network and then letting them have access to everything is probably not a good thing to go do. So it starts with understanding, who should have access and who shouldn't have access, and then you go defining that. So customers do that physically. Sometimes physically now, they just simply will not let you in to certain places. Then there's digital ways to go do that. There's firewalls, there's VPNs, there's authentication that you're going to put in, there's security from an endpoint perspective that you may want to build out. On all of that, all tying back to who should have access to what. There's the ability to view and edit programs. Who should have the capability of doing that? And how do you know you have the latest and greatest program running that should be running? That comes back to the conversation we had earlier about putting in a product like Asset Center that backs it up, that tracks who makes changes. And if you applied the right security, you always know what program should be running at each particular time. Then there's simple things like people don't think about the fact that you're going to have switches out there. Switches have ports on them. I've been in places where someone on third shift comes in and plugs in their iPad because we left the port open, right? And if you let anybody come in and plug in a device from outside that you don't know, you've now plugged in an unknown actor into your network, right? So these are things you need to be attentive about, like Like if you have ports on switches, they're not being used, make sure they're locked down. And on the flip side of that, I've also seen it where customers have so locked it down, then if you have somebody come in, they can't do anything. So that also comes back to policy. All right, if someone does have to come in and make a change, what is the policy? What is the appropriate access point for them to come in and get into your network? I'll also bring up wireless. Had conversations with wireless where somebody can pull up in their parking lot and hop on their wireless network, if assuming you had some of the right credentials, right? So there's things you should restrict on that as well. And beyond that, we get into, the systems. If somebody does have access, it's very typical in a manufacturing environment, because we cannot patch things easily a lot of times, as quickly as IT may want it to be done. But we've got to have plans for upgrading and patching our infrastructure on an appropriate schedule.
Yeah, for anyone, listening to this and red flags are going off, thinking about, all of these different ways that a network might be vulnerable, are there ways to protect a network even when you can't address all of the issues at once? Jacob, can you speak to that a little bit?
Yeah, so many times our customers will do a network assessment. When that network assessment comes back to them, it shows a huge list of vulnerabilities that they have in their environment. And it can seem very overwhelming. Where do I start with this? What's the cost going to be? And I think Janie actually did a really good job of answering this question already. One of the simple ways that you can address this is just through policy, right? Enforcing authentication where possible, locking out unused ports, restricting access where necessary for contractors or external people. And then there's also the case of equipment that potentially can't be updated. For example, many industrial applications might run on a outdated operating system like Windows XP that no longer receives security patches and is not supported anymore. So then we can take a look at the network design and, well, how can we protect this particular device, whether that's segmenting it off or the use of firewalls. There's many different ways to do it, and we can do that through a good network design itself. But yeah, I think those are ways that you can start right away to look at protecting your network, and then working through our network services group, working with McNaughton-McKay to help identify the risks and using our expertise to help you go through what those vulnerabilities are and make recommendations based on our experience.
I actually just dropped in our cybersecurity survey, which we're featuring this month from Rockwell on the website. I just put that in the chat for anyone who's interested in maybe starting there. Kevin, go ahead. You were saying
Yeah,
something.
just a quick comment that it is certainly possible to spend 6, 7, even more figures on cybersecurity for your industrial platforms. It doesn't have to be that way. The idiom comes to mind, how does one eat a whale? One bite at a time.
Mhm.
Do what you can within the budget that you have now. Include it every year. Include a budgetary line item every year for increasing your security. And over time, you'll get to that point where you have a secure environment. It doesn't have to all be done at once. Take the biggest leap you can, but then once you've made that leap, just keep chipping away at that iceberg, because it will eventually break, and it will eventually, you will be in a secure environment. So absolutely don't get overwhelmed by the enormity of the security fabric, if you will. Rather, take it in small chunks, do what you can, and then just keep moving forward with your security.
Kevin, like you said, you can spend any amount of money. There's corporations that have an entire security group that does this on top of the networks. But if you can carve out something, single focus that you could do in a week, for instance, you could start small. You're worried about physical access, somebody plugging in an iPad. Panduit has these great little physical Ethernet caps. They're minimal. You can plug those into your switches if you're worried about somebody coming and plugging those in. And then you can take your step up, and then you have your firewall. You can limit the MAC addresses to 2 devices. a lot of times what we see is these simple, easy to use features or protocols that Windows includes, or HMIs, the plug and play feature that's so easy. You plug in a mouse and it downloads the drivers for you. Um, Even looking at little protocols like this that you can turn off. And I mention that because you could have, for instance, a delivery person could be paid by a hacker to, come up to your counter and plug in a USB drive. Well, that plug and play feature automatically allows them to install drivers or execute a program. So just a simple turning off a protocol can be minimal to your budget if you don't have a large budget to implement an entire cybersecurity policy.
And uh, going back to what Rachel said and what Janie said, knowing what you need to do is a big step. Doing the questionnaire, the security questionnaire that Rachel just posted. Also taking a look at the Rockwell Security Posture Survey. Both are great tools at identifying very specifically on your production floor what your vulnerabilities are. From that perspective, you can then start the process of improving that security fabric and making it stronger.
I was going to bring up, in addition to that, there are software services you can buy. We work with Rockwell and a company called Claroty, for example, that can do continuous threat detection as well on your network. So especially if any of you are in critical infrastructure areas, those are things you might want to consider, because it can take time to do some of these other things that we've all pointed out here today. But if you need to know bad actors coming in, you may want to consider some of these continuous threat detection services, because they'll continually monitor your network for bad actors that may be coming on board. So they can help stop some of that before they come, and they can be infected by stuff like that.
And it's worth mentioning those tools are specifically designed for the OT space to know what the OT protocols are versus an IT environment. They are built to be passive as they need to be in order to not affect production, knowing the sensitivity of the networks that exist today. So they're designed with those types of things in mind.
Janie, you had mentioned Rockwell Automation and Claroty. There's actually a great webinar here on YouTube where they talk about cybersecurity and that posture assessment that Kevin mentioned. I'll add a link to that in the description of the video for anyone that wants to come back and take a look at that. Well, shifting gears again from security, unless there's anything else we want to touch on with security, is there anything else you guys wanted to add to this discussion before we move into performance?
The only thing I would finish, because we haven't brought it up so far, and I know sometimes people get tired of hearing about it, but a good security plan is about defense in depth. What you're trying to do is put in multiple layers of security. So a hacker, it's just not one and done. He gets in and has access to everything. He's got to get through multiple layers of things that you've put in his way to go do that. So that's where Kevin, Nick, everybody talked about, there's a lot of simple things you can do to be able to start building that defense in depth strategy. So that's the only thing I wanted to bring up.
Think like a hacker, right? Make it more difficult for them.
Yeah.
All right. Shifting into the other side, which we've talked about a little bit, performance and production. Nick, where do we start with modernizing infrastructure, and what are the benefits of having a modern and secure network on the factory floor?
So kind of where to start is, as the OT environment and devices are growing, everything's becoming, connected to this network, this Ethernet network, for whether it's communications, having visibility to everything, or if the office space, your plant manager or something is wanting some sort of analytics, what kind of scrap am I having? How often is this line going down? You want to think about growth, and also, what kind of traffic you may be wanting to get out of that production floor. So having kind of a good model of your network from your enterprise network all the way down to your floor IO. That can be helpful with the CPwE or Purdue model that Cisco and Rockwell have put out there. Getting that industrial DMZ, so kind of starting at that layer underneath your enterprise, kind of where your phones and your printers are, is kind of your industrial DMZ. That's where your security and depth comes into play. So in the enterprise, you have your firewall, like Kevin had mentioned, that protects you from the outside world. Your industrial DMZ is that next security layer in depth, where I would recommend switching your vendor of firewall, but you place a firewall there, and then some of your process servers, maybe your jump server or desktop server. That's how you're going to reach your automation equipment. But to modernize it is you want a visible and manageable network. You want it to be easy to get to everything and easy to diagnose and take account of everything. That starts with having managed switches, separating your network into subnets. You can do that a number of ways. You can do it maybe based off of the area of plant. Maybe you have it defined as north, south, east, west corners, and you can divide it that way, or maybe it's subnetted based on lines. However you seem that it's easy to separate, but the biggest thing is having it be visible to everything, having a count of devices and notation. Going back to the CPwE, is you have that industrial DMZ where you have that firewall place, the servers, but then your next layer down is the flow of traffic. So you have all these automation equipment that is wanting analytics from it somehow, or being able to be programmed from the office space. I mean, how nice is it for a controls engineer to sit in their office and say, hey, I got to make a quick change to the programming in this PLC? And having the visibility and managed network allows them to do that. Some benefits of having that modern network, again, is you have that, you can sit from your office space if you need to. But also in that industrial DMZ, you have that remote desktop server. Is maybe you've got somebody third shift again, needs some help, and they call in from home. By having that modern network, they could remote in right into that system and then be able to help at a moment's need. Instead of 2 o'clock in the morning, you get the phone call, hey, I need you to drive 45 minutes to the office.
I think some of the other things are, that you've got a network that's scalable. You put in the infrastructure. Now we want to add in a new crane, a new scale, a new whatever. That adding it onto the network, if you built your network backbone and you laid it out, it's not going to crater your network just by adding a new load onto it and stuff like that. So I think that scalability is very important in having your modern topology, and knowing you have that resiliency. You've built it for resiliency, so that you're not, any one thing's not going to take it down.
The engineers, we like to use a term that when we're looking at like growth, it's not an if a new device is going to bring down a network, it's a when, because more devices, they're channeling more traffic. So it's definitely it's a game of chance when you're saying, okay, I'm going to plug in this new driver, this new robot, and or I want 4K cameras out here on my quality line. Something will bring it down at some point, and having your scalable network and segmented can definitely help you eliminate that win.
And that circles back to some of the topics that we talked about already, in that, if you know what's on your network, what the expectations are for those devices, you can plan. And taking it a step further, knowing what you know now doesn't necessarily mean that the same design or the same knowledge you have now is going to apply once you add, right? So knowing what knowing what your limitations are, but then also designing for the future and adding. When you add on to your house, you don't generally just start throwing bricks around and throwing foundation in the ground. You have someone design it. So designing your additions, especially the larger ones, are going to be very helpful in making sure that you don't take a network that is operating okay now and toppling it over into a network that's really not functional any longer. We find a lot of networks that are at what we call the top layer, the tipping point, where they're functioning now, but you add 5, 10, 15 devices like Nick suggested, that one device, that last device that you add, tips over the network and starts creating cascading effects or problems that are kind of nebulous, right? Because in the OT world, usually what happens is that a device gets overloaded and it then kind of checks out of the network and stops functioning on the network. And it requires you to reset that device for it to get back to functionality. That's a very common sign that that device is overloaded in its communications on the network. And so designing what you do for the future so that you're not drastically increasing your packet counts and knowing what you have and knowing what those limitations are will help you modernize for the future.
Yeah, I think Nick brought up a good point. We was talking about collecting data. Now more and more of your IO devices are going to Ethernet because now we want to retrieve a lot more data from our end devices than we did before. And that's only going to increase over time as we get better and we get more tools and more AI-based tools that can go see what's going on there. I think I listened to a Rockwell seminar this morning. They have a goal within the next 2 years to get, almost 40% of their devices into smart devices, where they can get intelligence out of it. So it's got to be planned because a lot of times we tend to think of the network, above the PLC and how the PLCs connect to HMIs, to the business systems, to MES and all that. But it also pertains to the network underneath the PLC, from the PLC to all the IO. And especially as we're getting more and more intelligent IO, you've got to go plan that. The networks there of the past, for those of us old enough to remember that, they were always very fit for purpose, and you plugged them in and they played, and you really didn't have to do a huge amount of planning. But now with the whole advent of data and all of that, and if you want to keep the same performance on your network, you've got to plan that network a little bit better than you have in the past as well.
And modernization goes hand in hand with migration too. I think it's very relevant today that with supply chain constraints, certain chipsets are becoming less available, which is leading to certain products being discontinued at a faster rate than they might have in the past. So there's many legacy devices potentially in a manufacturing environment that as soon as they get discontinued, they're no longer available. Well, do you have a plan to for spare parts for those devices, or what the migration path looks like for those devices, and where you go in the future with those? So if one of those does fail, what do you do to get back up and running as soon as possible?
Great. I think we may have touched on this already, but just in case we have anything to add, this is our last question for our discussion today. And I'll direct it at Kevin. How can factories cut down on network errors and improve productivity through networking solutions?
Yeah, this has been a theme that we've touched on, not necessarily tying it directly back to errors, but we've definitely touched on several different themes throughout the conversation today that will help eliminate those errors. Making sure that you're minimizing the packet count as much as possible on your OT network. And what that means is segmenting your network, adding in managed switches. You can't really segment a network with an unmanaged switch. It doesn't really have the same effects. Adding firewalls between the IT space and the OT space. Windows devices are extremely chatty. They have a lot of extra stuff that they want to talk about. Well, your OT devices don't care about that at all. And if you are inflicting those packets on the OT devices, you're increasing the likelihood that they're going to get to that overload point that I mentioned before. We try, when we look at networks and we look at network communications, we look at how clean the communications are that are happening from device to device across the switch. And designing the network, redesigning the network if you already have a network, so that you are eliminating the Windows components out of your OT communications, and then maximizing your communication strengths in the way of using unicast traffic as opposed to multicast or broadcast traffic. All will help minimize those network errors and reduce the downtime that you suffer because you have to reset a device or replace a device, that kind of thing.
Something I'd like to add too is using the proper equipment for your automation floor. We've talked a lot about switches and kind of the logical space, protocols, things like that, but also your cabling. You've got your control panels that are on the floor. Maybe they're right next to some drives or something. So you got some vibration and EMF coming off of those drives. So having the properly shielded cables or running the proper cables inside the panels, making sure your jacketing is correct. You get some pretty nasty heat environments out there, corrosive, it takes the jacketing off, or, after years of vibration in a panel, some of those jacks become loose and, you lose connectivity to PLC. Well, the maintenance guy comes up there and wiggles the cable and it comes back on. Is looking not only at your networking infrastructure, but your infrastructure as a whole, having your fiber backbone, because it's pretty tolerant to vibration and EMF. Having the redundant links, just making sure and going through. Panduit has this wonderful kind of test that you can go through. It's this MICE rating. That'll tell you kind of what kind of cabling and infrastructure you need for your environment based off the conditions.
And to piggyback on what Nick just said, one thing that's commonly been done on the OT side of the fence is that when you have a control room or a main data room where your servers live, and you're trying to reach out across hundreds of square feet to the end of your facility, frequently what's happening is you have switch after switch after switch in a chain of switches between point A and point Z. And minimizing those switches between your data room and your endpoints is going to help with communications. Every switch in between point A and point Z has to review the packets that are being sent across them. And that takes time. So if you're working with tight timelines and you're trying to send information from one corner of your plant to the other, you want to minimize the number of times that packet has to stop, be reviewed by a switch, and then pass on to the next segment. You can do that through fiber. Fiber allows very high-speed communications between devices, as well as a very long distance channel or a long distance wire. So adding or including fiber into your design going into the future is definitely going the right direction and helping your data do its best job that it can.
And also using the proper infrastructure in place too. I know we've talked a lot about managed switches during this chat. One thing to mention is those managed switches are not all alike, right? They each have different functionality, capabilities, and there are managed switches that are built for the manufacturing environment, for the OT environment, that know what protocols to look for. And when it sees that protocol, it might know to prioritize that traffic. For example, SIP traffic for a motion application, when you know this is really important traffic, it's got to get from point A to point B as fast as possible. Well, that switch can identify that it's that type of traffic and make sure that that is prioritized above all else. So having the correct type of managed switches is also really critical and something that can help minimizing those errors that you might see.
Great, wonderful information here. We are coming up here on time, so I just want to go ahead and thank all of you so much for everything that you've given us to think about here today. We've talked about a lot of really great places to start with improving network security and efficiency. A big thank you to everyone that's here watching with us as well. We hope this session was informative and engaging for you. If we didn't get to your question today, or if you're watching this as a recording and you have questions for us, please reach out to us at macandmaclive@nc-mc.com or reach out to your local McNaughton-McKay branch location to speak with one of our experts. You can find our email address in the video description below, and of course on our website you can find all of our branch locations and contact information. If you haven't already, please subscribe to the McNaughton-McKay YouTube channel for more industry content like this, and we'll see you live again next month. Thank you, everyone. Have a great day.